In this section, what you're going to be doing is thinking about the advantages and the limitations of tables and graphs and equations. And for the purposes of this video, we're going to abbreviate. So always is going to be A, sometimes is going to be S, and never is going to be N. So you may not agree at first, but then think about each statement and see if you can figure out why a statement might be always true, sometimes true, or never true. So if you're thinking about tables, like in these first two, can you always use a table to determine an approximate value? Can you sometimes use a table to get an approximate value, or can you never use a table to get an approximate value? I would argue that you can always use a table to get an approximate value, but maybe not always an exact value. So sometimes, if you're lucky enough, you can get an exact value from a table, but you can generally get at least an approximate value from a table. Then move down a little bit, and now we're going to be thinking about graphs. So when you're looking at a graph, can you always, sometimes, or never use a graph to get an approximate value? And I would argue that you can always use a graph to get an approximate value, but it might be difficult to get exactly the value you want. So you can sometimes use a graph to get an exact value. And then moving on to equations. Now remember, when we used equations before, sometimes we would get too much precision. Like if we said, how many shirts do you need to sell to make $100? You might get an answer like 6.2 shirts, right? Or 6.75 shirts, when you can't really sell fractions of shirts. So it seems as though we can always use an equation to get an approximate value, and we can also use an equation to get an exact value. So equations, you can get the approximate value and you can get the exact value. So this part here, it's not so important that you have the answer that matches. The important part is that you think about this and think about what different tools are good for. Tables are great for getting approximate values, but maybe not as good about getting exact. Graphs are also really good for approximate values, but they might have some limitations, like maybe it's hard to read a graph to get an exact value. And then equations, those are pretty good all around, but the limitation of equations is they can be hard to visualize. A graph or a table might be more comfortable to look at than an equation. So equations are good for accuracy, but they're not maybe as clear when you're just looking at them trying to interpret the data. Now what you're going to do for the second part is practice writing functions that match this table of values. And then you're going to evaluate the function for an independent and the dependent value. So there's a lot of information here. Here's where you're going to write your function. Then you're going to evaluate your function when your independent variable is 12. So you're going to evaluate f of 12, or f when 12 is plugged in. And then you're also going to figure out or calculate what x would be, what your input would be if you're given the output of negative 145. So if negative 145 was here in this table, what would your x be? So that's what we're doing in this section. So the first thing I notice is that our x's are going up by 1. So from here to here, and then from here to here, and from here to here, and from here to here. Each time we're adding 1 in our x row. And then what I notice here is from negative 20 to 5, that's plus 25. And then from here to here, that's plus 25. From here to here, this is plus 25. And from here to here, that's plus 25. So what I learned from this information, remember x, that's our horizontal change, and y is our vertical change. So if we're doing rise over run, our slope is going to be 25 over 1, which simplifies to 25. So when it comes time to write our function, we know that our slope is going to be 25. Now, we also need to find our y-intercept. If we're writing our function in this form, general form, we're going to want it to be in this format. And remember, sometimes, instead of seeing the m in general form, you may also see an a. That means exactly the same thing. This is where you're going to put the slope, no matter what the variable is, and this is where you're going to put your y-intercept. Another thing to recall is that the y-intercept always happens when x equals 0. So to calculate our y-intercept, we have to think about what would the y value be right before the x value was 1, when the x value was 0. And if we're thinking about going backward or to the left or downward on a number line, we're going to be subtracting 25 each time. We already talked about that. 80 minus 25, 55 minus 25, 30 minus 25, 5 minus 25. Each time we're subtracting 25. So now we need to figure out what would y be when x equals 0. So what we're going to do is we're going to take negative 20, and then we're going to subtract 25 because that's our slope. And to find where x of 0, what y value would go with an x of 0, this is what we need to do. We need to go back another 25 steps. So negative 20 minus 25 is negative 45. And since our y-intercept always happens when x equals 0, we know that our y-intercept is negative 45. So we now know our slope is 25, and we know that our y-intercept is negative 45. So now we're definitely ready to write our function, our equation, because we have the two values that we need to plug in. So when we plug in our 25 for our slope, and we plug in our negative 45 for our y-intercept, we have our function written. Now we can use this function to do problem solving. We can use this function to calculate x values, and we can use this function to calculate y values, which are also f of x values. This means the same as y or output. So the first thing we want to do is calculate what does our output equal when our input equals 12. So to calculate that, you're going to substitute a 12 any place you see an x. So what we do is this means 25 times x, and since we're putting in a 12 for x, this will be 25 times 12. You'll simplify this, and then you'll subtract 45. So I'll leave you to do that math. 25 times 12 minus 45, and you'll have your result. Be sure to show your work so that later when you're looking at this to study for a test, you know where you got this answer. If you just put the answer, that will probably not mean much to you later. So now what we're seeing here is that we are given that the y is going to equal negative 145 because y is the output and f of x is the output. So we're given that y is going to equal negative 145. But we want to know, what does the x equal at that point? So what we're going to do is we're going to plug in what we know, or substitute what we know into our function. And we know that f of x is negative 145, and that equals 25x minus 45. And when you look at an equation and you only see one variable that's not identified, or that you don't know the value of just one variable, it's going to be possible to solve. So first, we're looking to isolate the 25x, and then after that, we're going to isolate the x. But our first step is to get the 25x by itself. So what we're going to do is do the opposite of minus 45, which is plus 45. And remember that whatever you do on the right-hand side of the equal, you have to do on the left-hand side as well. You always have to keep it balanced. So now, do some calculations. Negative 145 plus 45 is negative 100. (45) and negative 45, or negative 45 plus 45 equals 0. So these are going to be 0. 25x plus 0 is just 25x. And now we're ready to isolate the x. So to do that, we're going to divide by 25, because this means x times 25, and the opposite of times 25 is divided by 25. And whatever we do on the right of the equal, we have to do on the left. And so we're going to be left with 1x, which you can just write as x, equals negative 100 divided by 25 is negative 4. And you could also write it the other way. The order does not matter. So it's equally correct to say negative 4 equals x. Both of these mean exactly the same thing. And what you've discovered is when x equals negative 4, y would equal negative 145. And another way to write this would be f of negative 4 equals negative 145. And you have also discovered that when x equals negative 4, y equals negative 145. So you have continued filling out values in this table.